Okay, we're going to be looking at practice test 2, second half, problem number 4. As I stated before, to get the best out of these problems, whenever I ask a question or ask you to do a calculation, pause the video, give it a good effort yourself, and then continue the video. All right, we have a mass, 2,000 pounds, being pulled up an incline of angle theta. We are given the height of the incline is 5 feet. The length of the incline is 12 feet. That the coefficient of friction is 0.4. Question is, what is the minimum power of a motor that is pulling the crate if the crate moves at 1.5 feet per second? And we will assume that is a constant velocity. First thing is to draw a free body diagram for the object. We want to know the forces. I show here my free body diagram where I have the normal force, the force of tension, the gravitational force, and the force of friction. What are the components of the gravitational force? The gravitational x component is mg sine theta. The gravitational y component is mg cosine theta. And of course, your theta, if you look at it, here's the y-axis, and right in here is theta. And of course, my x component is this one, my y component is this one. What is Newton's second law for the forces in the x direction? And of course, the sum of the x forces is equal to 0, and that's going to be minus the friction force minus the force of gravity plus the force of tension. All that equals 0. Why? What about the y direction? Of course, the sum of forces in y direction is the normal force minus the y component of gravitational force. And that also is equal to 0. There's no motion along the y-axis. Fn, then, the normal force is equal to the y component of the gravitational force. How is the friction force related to the normal force? Of course, the frictional force is the coefficient of friction times the normal force, and that's equal to the coefficient of friction times the gravitational y component. Can we solve for Ft, the tension force? Ft is therefore equal to the component of the gravitational force in the x direction plus the force of friction, and that's equal to 1,507.2 pounds. What is the power? Of course, power is equal to force times velocity. In this case, it's going to be the force of tension times the velocity with which the block is being pulled, and that's going to be 1507.2 times 1.5 feet per second, and that gives 2260.7 pound per second. And that is end of problem. One quick note, mg, the force of gravity on the object, okay, is equal to 2,000 pounds. End of problem.